Okay, section 7 is basically about models, and not the type that walk on a runway, but about picking what something's going to look like. Okay, we've got 3 that we've learned so far: linear, quadratic, and exponential. Um, so you're going to be able to recognize each one of these things. Linear will always have an x term. Remember the formula y equals mx plus b. Quadratic will look like this: y equals ax squared plus bx plus c. And exponential will have our variable as an exponent. Remember, we already had y is equal to b to the power of x, so now we have a to the power times b to the power of x. So that's what each one is going to look like. And excuse me, we're going to move on. Okay, so what it's asking us to do is it's asking us to graph these points and then determine which one of them is which model. Okay, so these points right here, they turn out to be this type of a graph. So what would that be? You are correct, that would be a quadratic model. Okay, so that makes a quadratic formula. Then we have these 3. Imagine what they would look like. Maybe that's what you saw when you thought about it. That looks a lot like a exponential model. Okay, and then we have these points. See the difference between the x's and the y's? This is what it's going to look like, and that looks like a straight line. Okay, so take some time, graph these 2, look at what the points look like, and see what you would name it. Okay, it's either quadratic, exponential, or linear. Okay, now the rest of the problems are already going to be worked out on the screen. We're just going to simply go over them real quick. Okay, type of function, choosing using differences or ratios. So they're going to ask us to do it using a table. Now what we do is we notice that all of the x's are the same. It's all plus 1. And we notice here that we're subtracting 1 from each of the y values. So that means that this is linear. The differences are all constant. Okay, so this is a linear function. Because if we plotted all these, we would get a straight up graph that looked like, no wait, it would look like this. Yeah, okay, it would be going straight down like that. Okay, now in this case the x's are the same, plus 1, but the first time we look at the y values, you notice that they're all different. Okay, minus 0.25, minus, but when we go one step further, you see how these are all the same. Okay? So it's the second difference that are now constant, and that makes a quadratic. Okay? So when the first difference, excuse me, is the same, we know that it's linear, and when we have to move to the second one, we know that it's a quadratic. Okay, so put these ones into a chart, see what happens. You might have to only go to the first difference, or you might have to go to the second. See where that leads you. Okay. All right. And then what we have is we have got some real-world data here, and oftentimes it doesn't actually show up into a graph, into a specific type of one of these things: linear, exponential, or quadratic. But what we can do is we can determine the best possible model for the data. Okay. So this is the number of years and the value of something. Okay, so this is called depreciation. The minute you buy a car and you take it off the lot, it starts to lose its value. Okay, so even no matter how well you take care of it, you buy it, it's a little over $12,000. In 1 year, it's already dropped to a little over, what would that be? 11, no, something like that. Okay, all right. So what we do is we first test for a common ratio. We recognize the years are increasing by 1, but the value is depreciating all by the same number, okay, by about 0.88. Right? So from 1257 to that is one number. Now remember, for something to look quadratic, it has to kind of curve back up, but it doesn't look like it's doing that, and it's not linear. And since we found the difference to be about 0.88, we can assume that it's exponential. Okay, so we know that y is equal to a times b to the power of x. Okay. So I know that y is equal to a times b to the power of x. A is the initial value, 12,575. B would be the decay. I mean, sorry. Yeah. B would be the decay factor, how much it's depreciating each time. So here's what we get. Y is equal to 12,575 times 0.88x. Okay? And what we do is we just check two other points. Take two of the points that we know, 2,9750 and 4,7540, and plug them in and see if what we get is close to the correct answer. Okay, so I plug in 2 and 9750 in for x and y, or I plug in the 2 for x, and what I get is 9,738. Well, we should have gotten 9,750. It's pretty close. When we plug in 4, we get 7,541. Well, we should have gotten 7,540. So those are pretty close answers. So therefore, we would assume that this is an exponential graph, and this is the equation that works to represent it. Y is equal to 12,575 times 0.88 to the power of x. Okay, so it's taking the data, looking at the graph, seeing what it's going to look like. This one doesn't quite look linear. It looks like it's going to start to bottom out each time. So therefore, we go through the process of figuring out the table, put it into an equation, and check it. Right? All right. So here is the end. And basically here it's just asking which type of function. So this section won't be covered too much. I'll just put a few of these ones in here to keep you honest. But see which ones you think. Remember, linear, exponential, and quadratic. Those are the three types that we know. See ya.